Good afternoon, folks. Brian here. Sunday, November 10, 2024. Hope you're all well. See, everybody else is talking about this earthquake off of Cuba, so I thought I'd put in my 2 cents. No, I'll make it a quarter. I was looking for my red plaid shirt. I couldn't find it, so this blue one's going to have to do. Young fella. Paul, knock it off. It's not a mega quake. Paul Begley, he's one of the examples that people just blow things out of proportion. Make it like, ooh. Let me explain. So there's a geophysicist, Hiroyuki Tanaka, in Japan. I read his research paper, his work, on muons. He uses muons to view the inside, the interiors of volcanoes, volcanic, the chambers, and so forth. I found that quite interesting. So what muons are? Muons result from cosmic rays entering our atmosphere, and when they interact with the atmospheric atoms, a secondary change takes place, where showering particles, called muons, are created. And these muons do penetrate the Earth's crust. And when doing so, and when reaching silica-rich magma, causes what's called bubble nucleation, heating up the magma, pressurizing it. I'll get into my theory in a minute. Now, how much saturation or penetration that reaches us depends on a few things. Atmospheric pressure, atmospheric density, atmospheric temperatures. And I use this as my own personal predictive tool, along with my idea with what's happening with the outer core of our planet, where a magnetic field is generated from. The outer core expansion, where our mantle plumes are anchored to. So our mantle plumes are long columns of harder magma, which are anchored to the outer core where a magnetic field is generated from. They rise up to the underside of the lithosphere, and when they do, a mantle plume head is created. It could be thousands of kilometers in diameters, and my theory, my idea is it has extensions, arms, nodes, pushing up underneath the lithosphere. In which we walk upon. So before I go any further, a professional in a particular field will promote his own theories based on this training, education, but he may slide off course, say things that shouldn't say. Heart, excuse me, dry throat, heart. And that's very irresponsible. So I've taken that Japanese study and applied that to my own idea of the mantle plumes and the outer core expansion. And so once again, the muons cause bubble nucleation of silica-rich magma. And when that rises to the underside of the lithosphere, one of 3 things is going to happen. Remember, that's an energy. It still wants to get out. 1, volcanic eruptions. 2, earthquakes. 3, fires. Going back to the Japanese study, case in point, 1991, the Mount Pinatubo eruption in the Philippines. Right at the same time, or maybe one day following, a large typhoon, Yunya, passed through. Typhoon, large volcanic eruption. So what I have is my studies, accumulated observations, and tracking. And then I will make a suggestion to expect a seismic or volcanic response following the tracks of these hurricanes. Cases in point. Hurricane Beryl. Its track was heading directly over Martinique. I said to expect some earthquakes. Earthquake struck at Martinique, and another one struck right in the middle of the Caribbean plate, not on a fault line. Let me jump back. I'm going to explain something. So when we have a high pressure system, good weather, this increases the density. That in turn increases the chances that muons will be deflected away or bumped off its path as they shower down. My analogy I like to use, high pressure is like having an umbrella. So those muons will be deflected. They're not going to continue down, right? They'll be deflected. High pressure system. When we have a drop in barometric pressure, the parameters I put it at between 950 and 1,000 hectopascals. As the pressure decreases, so does the density and atmospheric temperature. So it's like that umbrella collapses on itself, allowing the increased showering particles of muons to penetrate the crust and so forth. So, as I've shown at least 6 times now, on June 30th was Hurricane Beryl. On July 2nd, 3.2 earthquake in the middle of the Caribbean plate. Then a 4.3 earthquake in Martinique. November 7th, tropical storm, Raphael. 4.3 earthquake where? In the middle of the Caribbean plate. The other people reporting on this earthquake in Cuba are not mentioning this because they're applying what they believe and what they know, and for the most part they are right. Ionospheric charging down to the lithosphere. It's going to come up through the faults. But there's been many other instances of earthquakes in the middle of the plate where the plate is the thinnest. Mountoplumes. And of course, today's 6.8, which followed after the 6.4, 5.9, something like that. Predictable. Now, as these storms track on through, there's never been any response in the Gulf of Mexico. As it turns and heads northward into the United States, then we start seeing some minor earthquake responses as far north as Ohio. So when you have those great thunderstorms and tornadoes tracking through there, that's when the earthquakes start up there. Point of observation. So it seems that the Caribbean plate is more susceptible to earthquakes following tropical depressions and hurricanes. Shown and proven several times. What should not be shown or even said is any suggestion of HAARP. Oh, 10 minutes. Okay. So yes, of course, yes. as we have an increase in space weather events, saturation, charging of the ionosphere down through into the lithosphere. Yes, of course, we know that. But why are earthquakes happening in the middle of the plate? There's been a substantial increase in the southwest corner of the Caribbean plate, north of Panama, as well as north offshore of Venezuela. A substantial increase in earthquakes all in that area. Why are you not reporting on that? Why are you not giving your theories on earthquakes happening in the middle of the Caribbean plate? Anyway, that's it for now.